Hello everyone. Now we are going to learn how to interface 16 by 2 LCD display with the Raspberry Pi Pico. As usual, we are working with MicroPython. Let's start our tutorial. These are the components that we need. We need a Raspberry Pi Pico and a 16 by 2 LCD module. The pins are already pre-soldered and we need a LCD to I2C module and 4 female to female jumper wires and a small breadboard. Now let's start our connection. Take out a breadboard and connect the I2C module to any one end of the breadboard. Make sure it is connected any one side. Yeah, like this one. Now we are good to go. Next, take out the LCD module and connect D0 pin to D0 pin. D0 pin is connected to D0 pin of the I2C module, like this one. As we know, I2C has two wires for communication, two wires per power supply. First one is SCL and SDA, VCC and ground. SL for serial clock, serial data, power supply and ground. SCL pin of I2C module is connected to SCL pin of our controller and SDA pin of our module to the SDA pin of our controller, VCC to VCC and ground to ground. Now we are going to identify RPI Pico I2C pins. As we observe, we can use a list of pins as SDA and list of pins SCL. For this particular tutorial, I am going to use I2C 0. Raspberry Pi Pico has two I2C interfaces. It has two I2C channels, probably. I'm going to use one channel, that is I2C 0. Here it is the connection diagram. SCL connected to PC1, SDA is connected to PC0, and VCC to the V system, and ground to ground pin. Now we are going to connect I2C module with our microcontroller. As we discussed earlier, SCL pin to GPI was 1, SDA pin to GPI was 0, VCC to V system and ground pin to ground. And that's it. This is all about the connection. Now we are going to come with programming. For the programming, initially we need to know the address of the I2C module. It is already mentioned on the back side of the I2C module by the manufacturer. For in most of the cases, the I2C address is not mentioned. So that's why we need to scan. Just go to File, Save on the controller, name it as I2C Scanner. This is a program what I found in web. I just simply copy and paste it here and run the code. And now make sure SCL pin and SDA pin, it is different with your own microcontroller, and at the same time we have different pins. If your device is not displayed here, please check with the connections. SCL pin is connected to SCL, SDA pin is connected to SDA, and power supply is properly connected. It is one type of verification code to verify whether the I2C module is working or not. It sends the information about the address of the module. Now we are done with the connections and we are done with the I2C scanner as well. We are already verified the I2C connection. It replies back with the I2C address. Now the library part. I found this library on internet. I'll give in the description so that you can download and use. Create a new folder with the name of lib, that means library. All the libraries are stored in this folder itself. This is the beauty of CircuitPython, to store all the libraries inside the our controller. Just paste it here and that's it. We can use this library in our program. Okay, now take a new project, import import board, bus IO, time module, and import LCD. If you observe on the LCD display, it has 2 rows and 16 columns. We need to specify exactly where we are writing our characters. This is the 0, 0 position and this is the 1, 0 position in the x-axis, and this is about y-axis. Just save the code and run on microcontroller and see the output on the right side corner. Now I am interested in displaying a custom symbol or a custom character on LCD display rather than alphabets, numbers, or which are predefined. Just open any browser on your computer and type custom character design on 16 by 2 LCD display. On the top first, you'll find this link. Go to this link. It has two options. We are working with I2C or parallel interface. You want binary information or hexadecimal. As we know, we are connected on I2C, so I choose I2C, and I'm with a hexadecimal code. Just select which pixel you need to turn on and which pixel we need to turn off. Just select those pictures. Just select those pixels, and here you can see on the right side the corresponding custom character code is built. So just go back to our just go back to Tony. Now I'm interested in showing onboard temperature on my LCD display. So for that, I'm going to take an variable called CPU underscore temper and load the, the current temperature into this variable and print. You can see the updated current temperature on the LCD screen, and that's it. In this lecture, we are understanding LCD module, and at the same time we are understanding the I2C interface. We learned how to scan and how to identify the address of I2C module, and we learned how to load libraries into CircuitPython device, and we learned how LCD module is work, and we learned how to show current temperature on LCD display. Thank you.